Okay, let's look at another problem similar to what we did in the previous video. Again, we have got a block which is hanging from support with the help of multiple strings. So a system is in equilibrium, consists of an object of weight W that hangs from three ropes as shown above. The tension in the three ropes is T1, T2, T3. Which of the following are correct for T2 and T3? So again we are going to label, draw on our diagram how T2 and T3 will look like. So T2 will be acting towards the support, T3 will also act towards the support like this. And we know that T1 and W will be exactly equal to each other, because if we look at T1 and W, they are going to be exactly equal to each other. So instead of drawing T1, we are just going to focus on W. And then we are going to figure out what is T2 in terms of W and what is T3 in terms of W. So first thing which we need to recognize is that T3 is not on the X or Y axis. So we need to resolve it. For that, first we need to get the X and Y axis on the diagram. So I'm just going to draw X and Y axis. Let's just label it. This is your X axis and this is Y axis. Now this we can see that is forming a Z, that is the alternate angle. These two lines are parallel. So if this angle is given as 60, this angle will also be 60. Now we can resolve T3. Along the x-axis we'll have T3 cosine 60, and along the y-axis we'll have T3 sine 60. Again, the system is in equilibrium, which is given to us. So in each direction the net force must be equal to 0. So for x-axis we are going to look at the forces which are along the x-axis, T2 and T3 cosine 60. They must be equal to each other as they are acting in opposite direction. So T2 should be equal to T3 cosine 60, and along the y-axis we can see there is T3 sine 60 up and W acting down. So let's write that T3 sine 60 will be equal to W. Now we want to get which of the following are correct values for T2 and T3, and you can see that there are different options given to us in terms of W. So we need to get T2 and T3 in terms of W. So T3 we can see it is W over sine 60. So that's the expression for T3 in terms of W. Now we can use this T3 in the first equation here, and we can get T2 also in terms of W. So that's what we'll do here. So T2 equal to T3, I'm going to write it as W over sine 60, which I got from here. Okay, multiplied by, we had cosine 60 already in the equation. So we can write this as T2 equal W cosine 60 over sine 60. Okay, now if we check the options, we don't have anything looking like what we have got. Instead we have something in terms of tan. So we need to rearrange this equation which we have got in terms of tan. You need to know that tan theta is equal to sine theta over cosine theta. So that means tan 60 will be sine 60 over cosine 60, which I can see here. I can see here there is sine 60 and then there is cosine 60. So I can write this as T2 equal W over sine 60 over cosine 60. So what I have done is I have just brought this cosine 60 down so that I can replace it by tan, which we can do mathematically. You can like bring cosine 60 down. So think of it as if you're dividing up by cosine 60 and down by cosine 60. So cosine 60 and cosine 60 in the numerator will cancel out. So you'll have nothing in the numerator, but in the denominator you will have sine 60 over cosine 60, which we can replace by tan 60. Okay, so now let's check T2 equal W over tan 60, which is here, and T3 is W over sine 60, which is this last one. So that means our answer is E. Okay, let's look at the next one, which is again based on Newton's second law. So we have got block X of mass 3 kg and block Y of mass 5 kg. Both are connected by a string and are on a level horizontal surface. There is negligible friction between the blocks. A force of 12 Newton is exerted on block Y. What is the tension in the string connecting the two blocks? So we want to find what's the tension in the string which is connecting the two blocks. Okay, so for that we need to figure out, so we have to first draw the free body diagrams. So if we look at the whole thing, so we can find out what's the acceleration of the whole system, because we have the total mass and we have the force which is acting on it. So on the total system, so let's write it like this. On the system means both X and Y together. The force acting, the net force acting on the system is 12 Newton, because they said that there is no friction between the blocks and the surface. And the total mass, so let's write it as total mass, which will be 3 plus 5, which is equal to 8 kg. So we can find out the acceleration of the system, which is F net over mass, so 12 over 8, which will give us as 1.5 meter per second square. Now why we need to find the acceleration? Because acceleration is something which will be same for X, Y and the system. They are all connected to each other. So it's a connected body system. So we'll have the same acceleration. Now to find the tension in the connecting blocks, I'm going to take X, because X is having only one force acting on it, and that will be the tension force because of this string. So if I just draw the free body diagram for X, the only force which is acting on it is the tension force. There is no friction on the ground. There's no friction between the block and the ground. So I can write T equal mass of X multiplied by acceleration. So T will be equal to mass of X is 3 times acceleration is 1.5, which will give the answer as 4.5 Newton. So that's our answer here.